So let's talk about some of the different categories on the periodic table. We'll start with metals. Metals are normally solids, which does seem to make sense. Mercury, however, exists in room temperature as a liquid. It is the only one. It's a little bit odd. Um, some other properties of metals. Metals are often shiny, which is why some of them make good jewelry. Um, they're also malleable, Mallleable, which means they can be bent or shaped. Again, which makes them good jewelry. Hammered into foils. We talked about that in the last unit. Gold foil is just gold hammered out real thin, kind of like aluminum foil, but they're made out of two different elements. Um, Metals are also ductile, which means they can be drawn really thin into wires. So they're used a lot for electricity wiring, stereos, inside your phone, things like that. Any place you need a wire, because they can be pulled real thin like that. Um, Oftentimes, metals are good conductors of heat and electricity, which is why they're used for cooking and things like that. Most of them have very high melting points and boiling points. Again, makes them good for using for pots and pans and wires, things you don't want to melt very easily. Um, and metal atoms often form positively charged ions when they dissolve. Um, so when they dissolve in water, they form these positively charged particles. Here's some examples of some metals. I have started filling in the symbol, but you can go ahead and finish them out. Some of them are very obvious metals: silver, gold, platinum, nickel. Some of them not as ones you would think. Potassium and sodium, they are both metals. Same with uranium. Um, but those are all the metals. Again, you can fill in the symbols on your own. Just look at a periodic table. Most of the periodic table is made of metals. The other category, obviously, we got metals, we got nonmetals. Um, Nonmetals can exist as both gases or solids. Gases, solids. Like oxygen is a gas, helium is a gas. Um, and in the nonmetal category, bromine is the only one that is a liquid at room temperature. So we got mercury up there in the metals, and bromine and the nonmetals are the only liquids. Nonmetals are very brittle, which means they break and snap. They don't bend, and cannot be rolled into wires or hammered into sheets. So you'll never get like carbon foil, because carbon is a nonmetal and it just doesn't work like that. Um, if you think of like charcoal briquette, that's carbon, or in your pencil, that's carbon. They break, they turn into dust. They are also poor conductors of heat and electricity. You'll never have a sulfur pot that you cook in. Second of all, because it stinks, but it's not a good conductor of heat. They're not shiny, they don't reflect light. Some of them exist in nature as what we call diatomic, T-O-M-I-C, diatomic molecules, which just means that they exist naturally bonded together. Most of these are gases, but hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. When you find oxygen, just say for example, or nitrogen, things that are in the air, out in nature, there are always two of them bonded together. You don't just find one oxygen atom floating around by itself. It's going to be attached to another one. We'll talk about that in a little more detail later on in the unit. But it is good to know that these 7 elements exist as diatomic molecules, which means they're two attached together. All right, couple more categories in the periodic table we want to look at here. The next one is something called metalloids. So metalloids are also solid at room temperature. Here's some examples. Oh, and I forgot to say, here's some examples of the nonmetals. I'll bring that back. We kind of talked about most of them, but there they are on your notes. These are the examples of the metalloids. They are solid at room temperature. They have some characteristics of metals, some characteristics of nonmetals. So they're kind of that halfway group. Silicon, boron, arsenic, germanium, antimony. Those are some examples. Again, look at your periodic table to fill in those symbols. So they're kind of the midway point. And you can see on the periodic table here down below that has everything kind of labeled. These are the metalloids here in this dark black line section. So we got nonmetals to the right, metals to the left. But they've kind of formed that midway point. The other important category we want to talk about are these things called noble gases. They are called what is inert, I-N-E-R-T, because they don't really react with anything else. As you will see in the next unit, they have a full outer shell of electrons, and so they won't really react with anything. They're happy just by themselves. And all of them are gases at room temperature. Here's some examples: helium, neon, krypton, and the like. And you can see when I move to the periodic table, they are all the ones in this 18th column right here. They are all the noble gases on that side. So those are the basic categories of elements. Let's just do some quick general stuff about the periodic table, which you see pictured here at the bottom of your notes. It is used to organize information about the elements. You might not know it yet, but you will. There are a whole lot of different things you can learn from this periodic table. Elements in the same group, which is the columns, are called groups. So we'll just put COLUMN right there. Tend to have similar properties. So that's why they're lined up this way. You saw that in the video we watched. So this is group 1, group 2. They're all numbered to 18. And things that are in the same group, and you'll see why in the next lesson, but they have similar characteristics, similar properties. The group 1 elements in this first column here are called alkali metals, A-L-K-A-L-I. Alkali metals, they are very reactive. Like sodium, when you put it in water, it'll explode. So they react very strongly. The group 2 elements are also pretty reactive, not as much as group 1, but they're very reactive. They're called alkaline earth metals, A-L-K-A-L-I-N-E. Besides the noble gases, those are really the only 2 columns that have names. The alkali metals in the first one and the alkaline earth metals in the second one. Both very, very reactive. And then if you'll scooch down to the bottom of your notes, if I can do that with all my stuff here. Elements 95 through 118, which is here in the bottom. Let me find where 95 starts. Here. This bottom section right here. And the rest of them, which aren't on this table, we're not going to talk about them in much detail at all, except for this right here. They have not been observed in nature at all. They have all been created in the lab, starting here with 95 and going all the way to 118. So because of that, they do have a special name. They're called synthetic elements. So from 95 all the way to 118, which 118, this doesn't list. Oh, I guess they're up here, huh? They do move back up here to 118. They're synthetic. Can't find them in nature anywhere.